Yes, I can see your screen.
Any problem? I don't think so, right?
So before you start, I have to mention that there are 8 students who have to who chose to present today. So we will divide the presentation among you. Okay. So we'll start with Kerem right now, and then
I can start next, sir.
yes, no problem. Okay, Kerem.
Okay, then let's start. Hello, everyone. Today I'm gonna try to introduce the topic of today. My presentation covers the historical developments of aircraft propulsion systems, their classification, and the different types of engines that used in modern aviation. Also, I'd like to inform you about the style of my presentation. Um, as you can see, I wrote some specific information about the related topic. I won't read them directly, so I will try to summarize them. If
Kerem,
there's no
we are
problem,
just seeing the first page of the
yeah,
presentation.
yeah, I'm aware of it. And if there's no problem, let's start with my content part. Here is the topic that I will mention in the following pages. And the first slide will be about propulsion system. A propulsion system is essentially a machine that generates thrust to move and forward. And in aircraft, this works through Newton's third law. Accelerating gas creates reaction, force to propel the plane, and working fluid's acceleration through the engine produces this thrust. Another part will be about historical things. In the early 18th, and powered flight seemed impossible due to inadequate power sources. Early attempts used clockwork and springs. Later experiments with steam promise. Frederick Stringfellows, know how to pronounce his name, but in 1868, steam-powered model was a key milestone, now preserved at the Smithsonian. And pioneers of flight, visionaries like Mozharsky, Maxim, and others made early attempts with steam-powered machines in the late 18th, while none achieved sustained flight. For example, Langley's 1896 aerodromes flew nearly a mile over the Potomac River, proving the concept's potential. And classification of turbojet and turbofan. Turbojets and compressed air, mix it with fuel, and expel high-speed exhaust for the thrust. And turbofans efficiency by adding a front fan that bypasses some air around the core, makes them quieter and the more fuel efficient, either for the commercial aviation. I can say about it, approximately all the commercial planes are used them because of their performance. I mean, I'm talking about the efficiency and its sounds. I mean, as I mentioned that before, it is more quieter than the turbojets. And classification of, I'm hearing a sound spot. Let me check 1 minute. It has to be matched Tarık, actually. Hocam, any problem? I didn't aware of it if there is.
What is the problem?
And Tarık says that slide in matched with my voice.
It
I
is
don't think
matched.
so, right?
I can see your slides and I can see and hear your voice neatly.
Yeah. Let's continue. And classification. Yeah. Classification of turboprop and turboelectric. Turboprops use turbines to drive propellers, perfect for regional flights, especially regional flights actually. And turboelectric systems are emerging technologies where turbines generate electricity to power motors, a promising future direction for cleaner aviation. And also, I want to add something about the turboprop. It cannot exceed the 500 kilometers per hour due to propeller aerodynamics. And other part will be covered the ramjets, scramjets, and classification and their classifications actually. And ramjets compress air using forward motion, working best at supersonic speeds. And scramjets take this further with supersonic combustion. And rockets differ by carrying their own oxidizer, making them essential for the space travel. Other parts will be covered the modern system. Today's commercial aircraft overwhelmingly use turbofans. Their brilliant design balance fuel efficiency, power, and the noise reduction by diverting some air around the combustion chamber. They achieve better performance, takeoff, and landing speeds. Let's a bit talk about the work principles of combustion chamber. I have a short video also about it. I will share this video after my talk. Firstly, high pressure air from the compressor enters the combustion chamber. Then fuel nozzles spray down mist of fuel generally used in, for example, jet A1 or F-gas. I'll mention what was F-gas, by the way. And then spark plug in piston engine or high temperature air in jet engine ignites the mixture. After that, the burning mixture produces high energy gases and spin turbine blades in jet engine. It generates thrust.
Excuse me, Kerem, are you changing the slides? Because it is at least slide number 10 right now. Are we okay?
Yes, hocam.
Okay.
I'm talking about the work principles of combustion chamber actually.
Okay, but you're not showing the combustion chamber to us right now.
I'm sorry.
You don't have any pictures from combustion chamber, right?
Yes, but I have a video about it.
Okay.
If you want, I can share this video firstly, then I
I
will
think
talk.
it's better to talk on the video rather than showing us
Okay.
just the engine.
You're still watching my screen, right?
Yeah, I see a piston in here.
And
Cylinder.
this
Okay.
is the combustion chamber. Let me explain it again if there's no problem. Firstly, high pressure air from the combustor enters the combustion chamber. Then fuel nozzles spray a dyne mist of fuel generally used in jet A1 or F-gas. Then spark plug, a piston engine or high temperature air in jet engines ignites the mixture. Then the burning mixture produces high energy gases, spin turbine blades in jet engine, it generates thrust, and push pistons, piston engines, it rotates crankshaft. After that, the final step, hot gases exit through the exhaust system, then creating thrust or expelling waste. Catch, I just mentioned gas, so I can explain it. What was that?
Can I ask something in here? What you're showing us is a piston engine, right?
No,
So,
yeah.
is it a piston engine or not?
It is a piston engine.
Okay. So
It's
can you tell me is if there is an aircraft which is using piston engine, or what is the similarity of piston engine to the jet engine? Can you tell me? Can you explain us a little bit?
mm, piston engines. Actually, it rotates the crankshaft, but in jet engine,
Mm-hmm.
it generates thrust,
Mm-hmm.
and so, there's a fuel nozzle in jet engine,
Mm-hmm.
and also they are used some kind of fuel like one or aviation mentioned that all. But if you're talking about the piston engine, there's a spark plug. Also in jet engine, they are using high temperature air for igniting the mixture gas inside there.
Mm-hmm.
And
So, what is actually a difference between a piston engine and a jet engine in terms of, I don't know if you take thermodynamics course or not right now. Do you take thermodynamics?
no, not yet.
Not yet.
So
Okay.
I don't have any specific idea of it, but I've just tried.
So what kind of engine do we have in our automobiles?
Automobiles, there are some similarities in car engines and aircraft engines.
What are those similarities? Can you explain to us?
Yes, actually, the other part of my slide will be
Mm-hmm.
about. So,
Yeah,
if there is
okay.
no problem, I can continue with that.
Yeah. Continue.
Okay. Before I start, I want to talk about gas. I just mentioned that the previous pages, if you catch that. So, what was avgas? It's a kind of aviation gasoline that is specialized. I'm sorry to pronunciation. Uh,
Specialized.
Specialized. A leaded
Mm-hmm.
fuel used in piston-powered aircraft engine. It has also high octane formulation. For that reason, it's a bit dangerous for our environment. And mm, sorry, piston engines. Yeah. Piston or reciprocating engines convert pressure into rotation, similar to car engines, but modified for aviation with dual ignition and air cooling. Then typically use gas and remain popular in light aircraft. So turbine engines. Gas turbines or combustion turbines are internal combustion engines that continuously burn fuel, and their key components are compressor, combustion chamber, and the turbine. They are working together to convert energy into the mechanical motion. And,
So, the difference between a piston engine and turbine engine is that a piston engine is intermittently working, but turbine engines are continuously working, right?
evet, yes,
Okay. What do we mean by intermittent working, intermittency in piston engines? Can you show us the slide of piston engine,
okay.
slide number 11? Yeah. So
Mhm,
in this slide, you can see that there is a cylinder, and there
mhm,
is inside there is a piston, and this piston is connected through a rod to the crankshaft, like what you have in your automobile engine. So there is intake valve and there is exhaust valve. In the fuel and air mixture will enter through the intake valve, and then with a spark of this plug, it will be burned and it will produce some energy, which derives the piston to the lower part. So when piston comes to the lower part, it will rotate the crankshaft.
Yeah.
And then by the action of inertia, it will go back to its first place, the piston, and by that time, the exhaust valve will be opened and the gases, the burnt gases, will be going out of this cylinder. But this will happen in intermittent. So there is a part that the intake valve will be opened, the air and fuel will come inside, and the piston will compress it, then a spark, and then expansion. So there are four main levels that they will happen intermittently inside the engine, piston engine. But if you go to the jet engine doesn't have this piston, doesn't have any cylinder. It's these actually levels that I told you in the piston engine are actually happening continuously in the jet engine. So this is the first difference between the piston engine and the jet engine. Okay, we can continue with. Thank you, Kerem, for your presentation so far. We can continue with the second participant if you want.
Okay hocam.
Of course, I will start them.
Yes. Ahmed, you can
Yes, sir.
start from the jet engines. Let's open your presentation and see what you have right now.
Which jet engine you mean?
Let's go slide by slide. Okay, in this slide, the slide number 3. Can you stop at the slide number 3?
Hocam, it remains actually how turbine engines work. If there's a part like this, he can continue with that.
Okay, now I will ask some questions. First question that I have in this slide, the classification of propulsion systems. So what do you actually show to us right now? Can you explain this slide to us?
Yeah, of course. This is slide showing that there's types of propulsion systems like air breathing engines and non-air breathing engines, like you see, and in this slide, turbojet and turbofan and turbopropan and turboshift, of course. All of them I'm explaining it in the next slides. But for the rockets, like a non-breathing engine, like the rocket has own how can I say it? One second.
So
The rocket,
what do we mean by air breathing and non-air breathing? Can you
of course,
explain?
the air breathing, like the airs come from outside to the engine and going with the fuel to the compression compositions of the chamber. And that's what's mean air breathing engines. And non-air breathing engine, like a rocket, they have their own carrying their own oxidizer and can operate in space or anywhere in any atmosphere. Like
Yeah,
no
okay.
need to air breathing. Like
Yeah. So you mean air breathing engines to work properly, they need atmosphere, they need air
yeah, of
to
course,
work.
atmosphere
But
air.
for the rockets, they have kind of engines that they carry their fuel as well as their
Yeah,
oxidizer
yeah,
together. So
oxidizer, like,
they
yeah,
don't need
like with
any
oxygen,
atmosphere or oxygen to burn the fuel.
of course,
That's why you can use rockets outside the atmosphere in space, right?
of course. Yes,
Mhm.
that's correct.
Okay. Okay. So can you tell us this no, A, B, and C? What are the turbojet, ramjet, scramjet? What are these? These are,
Turbojet,
I guess, all of these are, I guess, air breathing engines, right?
yeah, yes, there's air breathing engines, all of them, like
Mm-hmm.
turbojet engines. It's like it's simplest type of if engines, like turbine engines, mainly used in older fighter jet and early uh, jet aircraft. It's produced like there is by thrust by acceleration as term of air completely through the core of the engine. There's turbojet, like
Mm-hmm. Mm-hmm. Mm-hmm.
for the
Why do we call them as turbo? Do you know what does it mean, turbo?
actually I don't have idea about this.
So turbo means rotating, okay?
Yeah.
Rotating. Something that is rotating, we give a turbo prefix to that. So turbojet is a jet engine that has some rotating parts inside.
Yes.
Do we know what are the names of these rotating things inside the turbojet engine? Do we have a name for them?
I think, I don't know. Do we
Okay.
have?
What is the simplest engine? As you said, the turbojet engine is the simplest
Yeah,
engine.
turbojet engine is the
We
simplest type
have
of engine.
we
But
have
gas turbine engines,
as
yeah.
you show in here, we have a ramjet and scramjet engines. Do we have
Yes.
rotating parts in ramjet and scramjet engines as well?
I think
Something that is rotating inside the engine?
I don't know about if they have a rotate, like you see turbojet has spilling wing, like what's
Mhm, mhm,
splayed, like I don't know
mhm,
if
mhm, mhm.
the others
Yes. Yes, as Ahmed says, there are some wing-like or blade-like shapes inside the turbojet, but you cannot see them in ramjet and scramjet engines. That means
yes,
that the ramjet and scramjet engines are not turbo. They do not have any rotating parts inside them. So
yes,
in in turbojet engine, the parts that are rotating are either belong to compressor at the front part of the engine, which is shown by the compression in this slide, or they are belonging to turbine, which is after the compressor, you see a red part, which is combustion chamber. After combustion chamber, you see two stages of turbine blades. These are the blades of turbine, okay? So you see at the front part of turbojet engine, you see a number of levels, a number of stages of compressor blades. At the back
mhm,
part, you see turbine blades.
yes.
Okay, uh, go to the next slide, please.
Which one?
Yeah, the piston. In here, Ahmed shows us the principles of reciprocating motion. These uh, four-stroke engines that Kerem also showed us in his presentation. These are the levels, these are the stages of working of a reciprocating engine.
Yep. The
And
sections.
the reciprocating engines are mainly used in propeller aircrafts, as you see in this slide. The engine is connected, the crankshaft of the engine is connected to a propeller, as you see in here. So it would be A small aircraft with propellers.
Yes.
Okay, let's go to the next
There is
slide.
turbine engines they use on in helicopters also, like rotary motion.
Okay, can we go to the slide number 5? We cannot see
Of
the
course.
slide number 5.
Here.
Yeah. So you're showing us a helicopter blade,
Yes.
right?
Yeah.
But you said that in helicopters we use turbojet engines, right?
In helicopters, I don't know, like I like turbine engines operate like I don't know. I don't have any idea. Like I think
You don't
it's
have any idea. Okay, okay. So the helicopters are do not use reciprocating engines. Okay,
mm,
uh,
okay.
because the power that they need, the blade of helicopters need is uh, so beyond the power that can be generated from the reciprocating from the piston engines. That's why
Yes.
you have to use jet engines. But
Oh, okay.
it's not jet engine, you have to use turbine engines. And
Turbine.
it is a kind of turbine engine that you completely uh, translate all the kinematic energy inside the fuel and air, combusted fuel and air, to the shaft power. For the helicopter, you have to use shaft power. Okay,
Chef power. Yeah.
when
Yeah. Of course.
when
Yeah.
you
We have
use
to.
shaft power, then when you have an engine, a turbine engine that you deliver all the power to the shaft power, you don't call it turbojet engine. You call it turbo shaft engine.
Yeah. Okay. Yeah.
Okay?
That's correct. Like in the last slide I have that I explained
Yeah.
about the
Yeah.
helicopters. Yeah.
Okay, go to the slide number 6, please. Let's
Of
see what
course.
do you have in there.
There's for gas engine.
I cannot see a slide number 6 right now.
There's that's
Okay.
you see it now?
Yeah. Yeah. So in this slide, please tell us what is a gas turbine.
A gas turbine is a type of internal combustion engine that converts fuel into the thirst, like air, like fuel, like it's continuous combustion process. Uh, the air drawing into the engine compresses the air to the express pressure fuel and the fuel is added in the burned with the compressed air creating hot gases and then the hot gases spin the turbine blades powering the compressors and other systems like gases and as you see in the pictures show you the air how's the air going in the engines
Mm-hmm.
doing and compress in the composition chamber. Then the
Mm-hmm.
gas, the head gases make the plates powering the plates to spin.
Mm-hmm.
Then create the power for the jet to fly, or as you see
Mm-hmm. Mm-hmm. Okay. Go to the next slide, please.
here. Can you see, sir?
No. Yeah.
There's problem. Yeah.
So these are the types of air breathing engines.
Yes.
The first one is turbojets, and the second one is turbofan, turboprop, and turboshaft. Do you
Yeah.
know what are these? What is turbojet? What is turbofan?
So turbojet We explained just a while ago. For a turbo fan, I think we 1 minute. What is it like? Turbo fan was what? What's it?
The picture that you are
Yeah,
showing in
yeah,
here, what
yeah.
is it?
The turbofan is
Turbojet or is it turbofan?
like mostly commonly used in the modern airplanes. It combines large fan at front with the jet engines, core to the giving both high power and good fuel efficiency.
Hmm. This picture is which one of them? Turbojet, turbofan, turboprop, or turboshaft?
It's I think for turbofan. I think.
You just think, or you are sure that it
Yeah,
is
yeah,
a
yeah, yeah, I'm
turbofan?
sure. I'm sure it's for the turbofan. This picture.
Okay. Why is it turbofan then? Can you
Like because
explain to
the
me?
turbofan drawing like air it's not going directly in the engines, like 80% from the air goes around the engines and
Mm-hmm.
20% of the air is go through the engine.
So this 80% that you said, what do we call this 80% which is not going inside the engine? Do
Bypass
we?
fan air.
Yes, it is a bypass fan air, right? So the fan at the front, as you see, sucks the air inside, and part of it will go inside the engine. We call it core of the engine, in the center of the engine.
Yep.
So you see, it says fan air, and some part of it will be bypassed. We call it bypass air.
Yeah.
So this fan air will go then through the stages of compressor. Can you see the compressor here?
Yeah.
Where
There's
is it? Can you show it to us? The compressor.
the compressor.
Mm-hmm. Where is the
My
compressor?
Can you see my mouse?
Yes, I can see. Where is the compressor? Where is the fan for
There's the fan like here from here coming from fan air starting to get to the chamber of the composition of chamber.
no, no, just show me the fan. Point out the
Fan
fan.
like I don't understand what's the
So from left to right, the first thing that you see, what is it? From
from
left to right.
from here you mean, sir?
Yeah, from left to right. The first thing that you see,
Blade and fan air like from here.
yeah, the first part that you see, just show the first part that you see. Yeah, this is a
Here.
fan. This is a
Yeah,
fan.
there's a fan. Yeah,
Okay, and the fan is connected to uh, a set of gears, not those,
yeah.
not those, not those.
No,
Just after the
those you mean?
fan.
Yeah,
These are some gears. Okay, after those gears, you will see four sets of blades. Can you
yeah.
show it to us? Four sets of blades after the gears.
After the gears, like there.
No, just after the gears. These four sets of blades. These are compressor blades.
Yep.
Okay, after compressor, you see another. What is this?
Other gears, I think, are blades.
These,
Of
this also, this part that you are showing, can you go over by your mouse to the
course,
part
almost
that
there.
I,
There's
no, not those.
for those.
After these four sets of blades, after it, to the right, there is a part. Yeah,
Here.
this part, this part. This also has some blades, okay?
Oh, I don't
But
know.
this is also a compressor, but we call it a radial compressor because it is
Radio compressor. Okay.
diverting the air in radial direction to the top and bottom, as you see. Can you see?
Yeah,
It takes the air inside and then deliver it in 90 degrees angle. Yeah.
from
Then
here,
the air, then this air will go inside what? The
the
uh,
composition of chamber,
the combustion chamber.
combustion chamber.
The
This is,
combustion chamber. What
yeah,
happens inside the combustion chamber?
the fuel and the gas, the fuel and the oxygens,
Mm-hmm.
the pressure, there's pressure there makes the what it's called it gas make gas
Mm-hmm.
and then go outside from the like from here to the out of the engine.
So where do you have your flame inside the engine? Is it inside the compressor or is it inside the combustion chamber?
I think it's
When you
inside
mix,
combustion chamber.
yeah, combustion chamber is a place that you burn your fuel and air. Okay, the
Okay.
mixed fuel with air will be burnt inside the combustion chamber.
Yeah,
Okay, and when it is burnt, then it will pass through some other blades. Can you show us
this
after it
blade,
is burned? Before these three sets of blades, there is another.
this
No,
one here.
this one is a compressor. Huh, this one. Yeah,
Yeah.
this one. This one is also a turbine blade.
Mm.
Okay.
Yeah.
Yeah. After this one set of turbine blade, you see three more sets, three more stages of turbine blades,
Yeah.
right?
Yeah. Right.
Okay. Okay. What actually these turbine blades do? Do you know?
Like to push the gas out of the engine.
No, not actually. They don't push anything.
Yeah.
Actually, the gas that enters the turbine blade has already a very high kinetic energy.
Hmm.
So this high kinetic energy will rotate the turbine blades.
Okay.
Okay,
Okay.
when the turbine blades are rotated, because turbines are connected to the compressor blades through a shaft at the
Mhm.
center, they will rotate the compressor blades as well. Okay,
Yeah.
so
Got
high
you. Got
kinetic energy gas coming out from combustion chamber will enter the turbine blades. It will rotate the turbine blades, and because
you.
turbine blades are connected to the compressor blades through this central shaft, the shaft at the center of the engine, the
Mhm.
compressor blades will rotate. So when the compressor blades will rotate, the compressor blades are actually take the air from outside and compress the air to make it ready for the combustion.
Oh, okay.
So that's why this engine is working continuously without stop, and that's why we call
Yes.
it a turbojet engine, turbofan engine in this case.
Yeah.
Okay, thank you, Ahmed.
Thank you so
We
much,
we're
Ted.
gonna we're gonna uh Ahmed is done and Berat is here, I guess. Berat,
Efendim
Berat,
hocam,
Berat, I want you to continue, please.
I don't do my presentation. I didn't do my presentation
Okay.
because of my physics exam. I'm sorry for that.
Mm, I didn't ask you because of what. We are going to
I
continue
can
with
continue hocam.
mm, Melissa.
Yes hocam.
Yes, you can continue, Melissa.
Okay.
I have to go to uh, Harun.
Hocam ama paylaşamıyorum ekranı ben şu an, bir saniye.
Harun, there is a jet motor inside our campus, and next week I can arrange some time to take you there and show that jet engine to you. Okay, next week after the quiz. Is it okay for everyone? Inshallah. Okay, Melisa.
Baştan mı başlayayım yoksa açmamı istediğiniz bir yer var mı?
Melissa, let's do it slide by slide, and then I will ask you some questions, okay?
Okay.
Okay, this is your second slide. Go to the third slide, please.
Which one hocam?
Third one. Classification of propulsion. We already
Okay.
talked about them. Okay, the fourth slide. Slide number 4. Okay, can you tell us what are these?
Hocam, these are some types of engines.
Hmm.
Previously, my friends said.
Okay. What is the difference between a turbojet engine and a turbofan engine?
Hocam, actually, we have two main engines, piston engine and gas turbine engine.
Mm-hmm.
Piston engine uses pistons and turns propeller. It is good for slow planes. Gas turbine engine compresses air, burns fuel, and hot gases go out fast to make thrust. And turbojet, turbofan, turboprop, turboshafts, these are alt türleri.
Mm-hmm.
There are some small differences.
Mm-hmm. So a small difference between turbojet engine and a turbofan engine is what?
Turbojet engine pure jet thrust, very fast, but uses more fuel.
Mm-hmm.
We use this for fast military planes, aircraft.
Mm-hmm.
Turbofan mı demiştiniz hocam?
Mm-hmm.
It has a big fan in front. I can see.
Slide 4, slide number 4. Which one is turbofan in slide number 4?
Actually, it should be one more.
15. Slide
Yes.
15.
Sorry hocam. Ne demiştiniz hocam? Fanı mı sormuştunuz?
The difference between turbojet and turbofan.
Turbofan has a big fan in front, as you can see. It is more efficient, less noisy. It uses usually commercial aircrafts, Airbus, Boeing.
Airbus and Boeing. Yeah. Okay.
Yes, hocam.
So, can you show us a turboprop engine or turboshaft engine as well? Slide number 17.
17. It's turboprop. Turboprop engine turns propeller, but with a turbine. It's good for short flights. Usually middle-sized aircrafts, maybe.
Middle size. So it still has a turbo gas turbine. Can you tell me what is a gas turbine in this slide? But we are seeing some different parts. Okay, like you are showing to us a propeller, right? Can you show
Yes.
us a propeller? The propeller.
Mhm.
Then there is a gearbox connected to the propeller.
Yes.
Okay, and this gearbox
It's
is
more
connected.
basic.
Yeah, it is connected to what? The gearbox is connected to compressor, right?
Yes.
Yeah. This green part is called compressor. And this compressor is connected to something else, which is called turbine or turbine at the back of this engine. Turbine.
Yes.
Can you show the turbine with your mouse?
Turbine. This is.
Mm-hmm. After the turbine, you see exhaust. The exhaust. So the
Yes,
burnt
exhaust.
gases will go outside the engine.
Yes, exhaust
So
nozzle.
yeah. So a gas turbine is actually composed of compressor, combustion chamber, and turbine. We call these three together a gas turbine, right?
Yes.
When this gas turbine is connected to a propeller, like what Melissa shows us, we call it a turbo prop engine. Do you get what I mean?
No.
No. What is a gas turbine? A gas turbine is actually a set of compressor, combustion chamber, and turbine.
Yes.
So when you attach a compressor to combustion chamber and then you will attach a turbine to it, we call these three together a gas turbine. So you have a gas turbine here which is connected to a propeller with this shaft and gearbox in the middle. When you
Yeah.
connect a gas turbine to propeller, we call this engine as a turboprop engine. Is it clear or not?
Yes, I understand.
Do we have any slides which shows us a turbo shaft engine?
It should be. Uh, yes.
Mm-hmm. Mm-hmm. Mm-hmm.
Uh,
So do we still have a gas turbine in here?
yes. Turbine.
Yes, because you have compressor, combustion chamber, and turbine. Can you show them to us? Compressor,
This is.
combustion chamber, yeah, and then turbine. How many turbines does it have?
Yes.
It has two types of turbines. The first turbine is after the combustion chamber, to the right of the combustion chamber. It is called what? What does it say? Compressor turbine. And the second one, it says free turbine or power turbine. Can you see them?
Yes.
So compressor turbine, in the previous slide, I told you that the turbine is there to rotate the compressor, right? When the hot gases will hit the turbine blades, they will rotate the turbine, and this turbine will rotate the compressor. So the first turbine at the left, which is called compressor turbine, is actually rotating the compressor. But there is another turbine that is not connected to the left turbine. It is a free or power turbine. Can you show the power turbine to us again? Yeah. This turbine can in the middle, in between of this turbine and the compressor turbine, you don't see any shaft. It means that they are not rotating with each other. The free turbine can rotate freely. Okay, but it is connected to a power shaft. Can you show us the power shaft? Yeah. This means that there is an amount of energy that the free turbine or power turbine absorbs from the flow, and it rotates the shaft. So you can attach this shaft to, for example, helicopter blades, to just rotate the blades of the helicopter. That's why you call this configuration as a turbo shaft engine. Do you understand what I mean?
Yes hocam. We
Okay,
have
if you don't understand, we are recording this meeting, so again you can go over to my voice and check it. Okay, because I'm gonna ask these from you, the differences between all of these kinds of things.
tekrar mı anlatmamı istiyorsunuz yoksa?
So
Sesim geliyor mu?
I guess you understood somehow. I'm gonna ask all of these in the exam from
Okay.
you.
Hocam,
Okay, what else? What else do you have to show to us? For example, slide
Ramj,
13. 20. Slide 21 is good. Go to 21.
hocam, ramjet engine is a type of engine that doesn't have moving parts. If you want, I can see
So
from here.
what are the moving parts that you said? The moving parts inside turbojet engine. What
Like
are those?
like propeller.
No, not propeller. In a turbojet engine, go back to the turbojet engine. Which slide was it? Turbojet. Okay. Which one of these are moving parts? From the left to right, air will go inside the engine, okay?
Is it turbine? Turbine?
Yes, turbine is rotating, turbine is moving, and turbine is actually connected to what? At the front?
Compression.
To the compressor. These are all compressor blades, okay? So we have two sets of blades rotating, moving inside the turbojet engine. Compressor blades and turbine blades. Okay?
Mhm.
Now go to the ramjet engine.
Okay.
Do you see any compressor blades or turbine blades in here?
No.
No, there are no blades inside. No
Uh,
blades. No rotating parts.
It
Okay.
works by compressing air when the aircraft moves fast.
Okay. There is
doesn't-
one problem with ramjet engine.
It doesn't
Because-
work low speeds.
Exactly. Ramjet cannot work at low speeds. It cannot work at when you are on the ground. It cannot be used to take off the aircraft. The ramjet engine has no static thrust. You cannot make thrust force from zero by using the ramjet engine. Okay, this is bad about it, but the good thing about it doesn't have any rotating parts, so you can use it in very high speeds without any problem. Okay, because the action of compressing the air happens with the ram effect of the air in ramjet engines. You will see the details of these in your propulsion course. But I just want to mention the different kind of engines to you. These are the basic things that you have to know about the engines. Okay. Do you know what is a scramjet engine, Melissa?
scramjet. I don't know.
You don't know. Okay. Thank you, Melissa, for your presentation. We can continue with one other guy, İrem, Ortapınar, Kerim.
I can continue.
Yes, Kerim. Please open your presentation.
Okay.
Is this your presentation? Eren will present after Kerim.
Can you show my screen?
We can see your screen. So
Okay.
after Berner, I asked Melissa one question. Can you answer that question?
Scramjet engines?
Scramjets. What are scramjets?
I don't have any idea.
You don't have any idea.
I research just ramjet engines.
Okay. The one thing that I really like about this presentation from Kerim is that he didn't put too much text. He only put figures and photos to us, and as big as possible. This is a very good presentation.
Thank you.
For an online presentation. Thank you for that, Kerim. Let's go to the top of the presentation and go slide by slide.
Okay. Firstly, we can start the aero piston engines. Piston engines will start with Wright brothers' first powered flight. The first powered flight in history was made by Wilbur and Orville Wright on December 17, 1903. These aircraft is Wright Flyer. The Wright Flyer was powered by 12 horsepower, 4-cylinder gasoline engine. In fact, gasoline engine as a type of piston engine, because piston engine was used gasoline for work to work. How piston engines to show a video for you. If we look at the first step, intake, step compression, third step is combustion, and fourth step is exhaust.
Yes, could you please leave the link for this video on the messages so everybody can go over the video after the course? This is good for us. Just leave the link for us. Thank you. Okay, go on.
The most well-known gasoline and diesel engines today are internal combustion piston engines called for stroke engines. In fact, piston engines are used in the car or aircraft, but mm, but some differences to two situations. For example, V-type or radial type, birçok a lot of type of I am sorry. Piston engines have a lot of type, radial engines, inline engines, and supercharged. I will explain radial engines in this part. A major advancement in piston engines for came with the development of the radial engine, where cylinders are in a pattern around the central crankshaft. In fact, radial engines aim is increased power. Radial engines allow for higher power output relative to their weight, which was critical for early aircraft that needed power for flight. Mm, Also, these engines can cause durability cooling because they allow for better cool naturally airflow in a radial pattern of others because this is in front of the aircraft and it mm, it compression the airflow directly. Also, uh, in 1901, the radial engine made appearance. American engineer Charles Matthews Manley converted one of Stephen Baldr's unsuccessful rotary engines into a weather called five-cylinder radial engine. Manley subsequently installed this engine at uh, Lange's Aerodrome A and was able to produce 52 HP and 950 RPM, a significant improvement over the 12 HP and 1025 RPM over the Charles Taylor engine used right flying. Lane in part inline engines where cylindricals are in a single row. Prominent in the 20s and 30s. These engines were typically more aerodynamic radial engines due to their compact streamlined shape. We will structure. We can inline engine part. We showed back side radial engine. Inline engines in smaller and lighter, so we have to aerodynamic design aircraft because weight is the most important thing for aerodynamic. If we have more weight, we have to use materials. This is can this I am sorry.
Okay, I guess
This is can code.
I guess we can skip this part and please
Okay.
continue to the jet engines, the slides belonging to the jet engines.
Okay. We take, if you look jet engines, first turbo engines. Turbojet engines was the type of jet engines developed and played an important role in aviation history, particularly in military aircraft and the jet power aircraft. Operating principle, air intake in this outlet combustion and exhaust. I want to show short video for you. In this part, intake, airflow, that compression in this part, combustion and turbine. I will explain separately. Air intake, air enters the engine through a high-speed inlet. After that, compression air is compressed by an axial or centrifugal compressor, increasing its pressure and temperature. After that combustion, compressed air is mixed with fuel in the combustion chamber. It's combustion chamber. Combustion chamber and ignition. This produces high temperature, high pressure gases. High pressure gas is exit, and is spin because expanding gas for the turbine, causing it to spin. The turbine is connected to the compressor by a shaft, which proceeds. Final exhaust, hot gases are through a high-speed node that produces thrust according to Newton's third Newton's third law. We have the we have the we have the impact. We can take a reaction for this, and our airflow is our gas is exit, and our turbine is go.
Okay, just let me ask something from this slide. On what kind of principles this turbojet engine works for us? How do we get the thrust force, let's say?
God is exit in high velocity and pressure. So our we can we know the Newton's third law.
Yes,
Our
exactly.
motor is our engine is. I'm sorry.
So this is the jet engine is working based on the Newton's third law of motion.
Yes.
When there is an action, there will be a reaction. So what is action? What is reaction in this manner? What is
Actually,
action?
action is exhaust our gas. Reaction is the
Thrust
speed.
force.
Yes, thrust force.
The action is exhaust gases that go outside of the engine with very high velocity,
Yes.
and the reaction to that is the force that actually the propulsion force, which is called the thrust force, that pushes your aircraft to the front, right?
Yes.
So using the jet engines, it seems that you cannot go backwards. Am I right?
Yes.
So how do aircrafts go backward then?
Oh, I am sorry. If we exhaust gas, we can motion in go down.
We can go down.
Yes.
How do we go backwards? If
Our
if
action
the
is
engine
backwards. Our reaction is
forward, right?
yes.
When the action is backward,
Opposite
the
direction.
reaction is forward. So
Yes.
the aircraft
Opposite
cannot.
direction.
So the aircraft cannot move backward, right?
Yes.
So if there is a need for aircraft to go backward, then how do we do it?
I don't know. I don't have any idea.
So have you traveled with aircraft? Yeah?
I can't understand.
Did you travel with aircraft? Did you?
Yes.
Okay.
No.
You didn't use any aircraft so
No.
far in your life?
Yes. I cannot use aircraft.
Okay. So didn't you see an aircraft that taxiing on the runway? Did you see in the movies or somewhere aircrafts taxiing on the runway? There are
Okay.
kind of pushback tracks that take the aircraft backwards. Do you see them? Have you seen them so far or not? No?
No.
Okay. Okay. There are some pushback tractors that push your aircraft backwards. They can push your aircraft backwards.
Okay.
Okay. Okay. Thank you, Kerim, for your presentation.
Thank you.
Next we're gonna have who was it? It was
I am here hocam.
Eren.
Yes.
Yes, Eren. We are hearing you.
I am trying to reflect to my presentation.
Okay. You're still trying to reflect your
Yes.
presentation?
Yes.
Yusuf Güneş is here. Is he here?
Yes hocam, I'm here.
Are you going to present or not, Yusuf?
Sıra varsa sunarım hocam, no problem.
Can you see that?
Yes, we can see. So after Eren, we will have İrem and then Yusuf.
Okay.
Okay, Eren, just go.
Firstly, I am starting with
Continue on. Go over your slides page by page, Then I'm gonna ask you some stuff. Go to the page 3,
Okay.
slide 3. Okay, what do we see in here?
Air breathing
breathing.
engines and non-air breathing engines.
Okay.
Non-air breathing engines is using in are using in the space
Yes.
generally
Okay. Okay.
without air.
Mm-hmm. Mm-hmm.
Uh,
Okay, next slide.
yes.
Piston and turbine engines.
We are seeing in the middle of the screen piston engines and right of the screen.
Mm-hmm.
In the middle of the screen, we are seeing radial engine,
Mm-hmm.
and we are seeing type of gas turbines.
Mm-hmm.
There is turbojet, turbofan, turboprop, and afterburning turbojet.
Can you tell us a little bit about afterburner? What is afterburner?
It's about we have one page
Mm-hmm.
in here.
Okay.
We are using afterburning for the increase the thrust.
Mm-hmm.
We are spending extra fuel to the nozzle part.
Mm-hmm. Can you show us the nozzle in this slide? Where is the nozzle? No,
There
that's
is
not the first nozzle.
Huh.
The first nozzle is
Here.
go. Yeah, there. This is the first nozzle. Okay.
Yes. Okay.
In a go to the slide number 5.
Yes.
Okay. In this slide, the first nozzle can you show us the first nozzle in here? Yeah,
We are
exactly.
seeing here.
This is the start of the nozzle, and then the gases will go outside. This is a nozzle. Okay.
Okay.
So the same thing, if you go to the slide 6, you can see the same thing. Yeah, until here. This is the first nozzle. After this nozzle, you will have some pipes, and these are injectors for the afterburner. The excess amount of fuel will be again mixed with the burned gases, and then again they will be ignited, and inside the afterburner they will be combusted again to get more energy from the fuel, and then it will go pass through a variable nozzle. Can you show us the variable nozzle at the back? Yeah. So why do we call it variable nozzle? Because it can change the size of the nozzle. Have you ever seen any aircrafts with nozzles at the back, variable nozzles at the back? You can search for videos on YouTube when the afterburner of an aircraft is engaged inside the engine, then the nozzle size will be changed. So you will understand, and you will see all the related stuff about these variable nozzles and the flow inside the convergent divergent nozzles in your aerodynamics 2 course. Okay, aerodynamics 2.
Yes.
Okay, go on. 6, 7. So yeah, this is good. This is a good slide. So perhaps right now you can tell me what is the difference between ramjet and scramjet. From at the left, you're seeing what? Ramjet engine, right?
We are using more we are producing more energy thanks to this engine because we don't use any plate
Blade.
and fan.
Yeah, there are no rotating parts inside this
Yes.
engine, the ramjet engine. So, what is a scramjet engine?
I don't understand.
A scramjet engine. This is a ramjet engine at the left. At the right, you're showing us a scramjet engine. What is a scramjet?
We are using supersonic speed in scramjet.
Inside the combustion chamber of the engine, the combustion happens with supersonic speed. Okay?
Yes.
Normally, for the combustion means what? Mixing fuel and air and yanma odası. Mixing fuel and air and burning it. It happens inside combustion chamber. So for a good combustion, normally we have to reduce the speed of air, okay, to mix it properly with the fuel. Because if it is very fast, then the air does not have appropriate time to mix with the fuel. But if you manage somehow to make the combustion happen at very high speeds, namely supersonic speeds, then you will call this engine as scramjet. S for supersonic, C for combustion. Supersonic combustion ramjet. It is scramjet. Harun sürekli bize şey atıyor arkadaşlar şurada. Sayı atıyor bize. Mah 9.8 yani. Thank you, Harun. Okay, go to the next slide. Okay, these are related to the thermodynamics. Actually, you will see these in your thermodynamics 2, I guess, course. The cycle that the engine is working is called a Brighton cycle. So, thank you, Aaron, for giving this to us. But right now, I guess we don't have any time to go over this. So you will see it in thermodynamics. You can memorize the name of Brighton. It's a Brighton cycle. So do you know which cycle is related to the piston engines? What do we call a piston engine cycle?
It's about right of the screen.
No, this is again the Brighton. The 4-stroke engine that we have in our cars as well. Is it again Brighton cycle, or do we call it something else? Did you have any names of Otto cycle or diesel cycle in your high school? Do you remember? Otto cycle.
I am not remember that.
Okay. What about Carnot cycle? No?
No,
Okay, no problem. Go to the next slide, please.
it's about sources.
It's about sources. Okay, so you're very your presentation is very brief. Okay, thank you, Aaron.
You are
Let's have
welcome.
Irem for her presentation.
See you
Yes,
later.
sir. Can you hear my voice?
Yes, we can hear your voice.
Okay. Can you see my presentation?
No,
No.
I can see.
Okay. Can I start from the beginning, or if you want?
We go slide by slide, and I will be
Okay.
asking questions.
Here's
Okay.
my content and
Mm-hmm.
title. And from human to the power.
What is this aircraft that you're showing to us?
I didn't understand.
The aircraft that you're showing to us, what is it?
It's calm. I just want
Is it?
to put it. No, I don't want to say anything about it.
Mm-hmm. Okay.
I divided parts of history of aircraft propulsion systems, and these are the parts of it.
Mm-hmm. So what do you have for modern technologies? What are those modern technologies?
Modern technologies. I have Aviation Alice, all-electric passenger aircraft. It's a great example for modern propulsion technologies. The next generation of green flight is an example. Innovation in electric motors and battery technology are setting the stage for quiet, clean, and efficient air travel. And it's the biggest example for modern propulsion technologies.
So they do not use any fuel inside their aircrafts, right? What
Yes,
do they use? Is it all electrical?
I think it should be because it's all electric passenger aircraft. So there's no fuel, I think. And classification of propulsion systems, types of, and
Okay, we already talked about piston engines,
yes,
types of
and
piston engines. Okay, gas turbines.
gas turbines. How does it work or inside a gas turbine? And then aerating engines, and I can summarize one by one working
Yeah,
principles.
let's wrap it up like this. So, turbojet, you can see it in here. Then,
Yes. Turbojets, air enters the intake and is compressed by actual compressors. Fuel is added in the combustion chamber and ignited.
combustion.
The resulting high-speed exhaust gases pass through turbines and exist throughout the nozzle to create thrusts. And usually we use turbojets in old military jets. Then after burning turbojets, say as a turbojet, but a burner section where additional fuel is sprayed and ignited after the turbine. And we usually use it in modern fight jets. And turbofan, similar to turbojets, but with a large fan at the front.
Okay, we already talked about the turbofan. Go to the next one. Okay, the difference between turbojet and turboprop is that you have a problem.
Turbofan uses jet fan, turboprop use propeller. It's the difference between them. Turboshaft and ramjet. Finally, I have.
Turboshaft is where do we use the turboshaft?
We use turboshaft helicopters usually.
In helicopters, exactly.
Yes.
Exactly. Okay.
And finally, I have ramjet and the source.
And the source. Okay. Okay. Thank you,
You're welcome.
Iran. And finally, we will have Yusuf.
Okay, hocam. Shall I start?
Yeah, of course.
Okay.
Okay.
Okay, can you see my presentation?
Yes, we can see. Please go slide by slide.
Okay. First, I started with the history of aircraft propulsion system,
Next slide,
then
please.
the classification of propulsion systems. There are two features. Then I start with piston and turbine engine. Turbine engine, types of turbine engine, how does they work?
Mhm.
Then turbojet, afterburner, turbofan, and what is bypass ratio?
Ratio. What is bypass ratio?
Bypass ratio is the ratio of first. I want to tell here is air sucked, and the air goes from here and by the core, and the ratio of this is called bypass ratio.
Yes, exactly.
Is turboprop, turboshaft, and plus one is ramjet.
Is that all?
Yes, this is all my presentation. If you want any specific slide that
So
I want
can you tell me what is a gas turbine? What is a gas turbine?
I didn't research gas turbine, but I listen you. Gas turbine is where is anywhere here in the middle of the engine, I guess.
Yes, exactly. Thank you very much. It starts from
Okay.
compressor
Yes.
and then combustion chamber and turbine. Yeah.
Yes.
So when you attach these three together, you will call it a gas turbine. So
Mhm.
when this gas turbine becomes a turbojet engine, when you attach a nozzle at the back of the turbine, right?
Here, me.
So
Nozzle.
if you attach a nozzle at the back of the turbine,
Mhm.
you will make a turbojet engine. So if you
Okay.
attach a fan at the front of turbojet engine, it
You
will
will get, I
become
guess,
a turbo
turbofan.
fan engine.
Yes.
Okay. Okay. I guess you understood somehow the differences between these jets
Mhm.
engines and the whole idea of the propulsion of aircraft. So thank you. Thank you very much. Next week, you will have a second quiz, and as it is written in classroom, it will be thorough. It will cover all the topics so far. So please be ready for this quiz next week. After the quiz, we will go and we will check our engine inside the university as well together. And what else? Do you have any questions? Or Yusuf, by the way, thank you for your presentation. You can close the presentation right now.
Okay.
For the next week, you already know what are the subjects for the next week, and we will have 6 students to present for the next week. Do we have any questions or? No. Next week will not be online. I just told you we will go and check the jet engine, Mirage, together. We cannot do it online, okay? Okay. And thanks, Harun, for the numbers that he's giving for us time by time. Thanks to Tariq for giving about the pushback tractors explanation. And if there is no questions, we can end today's lecture. Thank you everyone for your participation. This meeting was recorded and I will put it on the classroom, the record file, so you can come back and check it. Okay, everyone, have a good day. Have a good weekend. See you.